Hey there, scientists, and welcome to another PS Science video. I'm Miss Oyenoki, and you might be wondering, what's with the costume? Well, I was inspired by this book, May Among the Stars. It's based on the real-life story of astronaut Mae Jemison. Have you ever wanted to go to space? I have. I've always wondered, how do those rockets get up there?
Today, we're going to engineer a paper and straw rocket. Let's gather our materials. You need some paper. Any kind of paper will work, as long as it's not too thick. A ruler, a writing tool, and some straws. You can use any kind of straws you have, paper straws from a restaurant, if you have plastic straws at home, or even a reusable straw like a metal or those rubbery ones will work fine. You also need some tape. But first, before we start constructing, we need to plan. So I'm going to come back here, and I've got a big piece of paper up here, and I'm just going to start sketching my rocket, what I think a rocket should look like. I know that it's going to have a straw inside. Now, I need to think of my shape. Rockets usually are a cylindrical shape like that, and then the other parts that they have. They're not usually flat on the front. They usually have a point. And then they usually have something that looks like wings. We call them fins. I'm going to write that here, fins. And then they have a body. And then this thing that we call the nose, we can actually call it a nose. So those are the parts that I'm going to be making for my rocket. Let's get started. First thing we're going to do is take our piece of paper, just one, and we need to make a 6-inch by 6-inch square. This is 6 inches right here. So I'm first going to mark on my paper. I'm going to measure from the bottom 6 inches and just make a little mark. And then I'm going to measure across the bottom 6 inches and make a little mark. And now all I have to do is make a line across my paper at 6 inches, and then make a line from the bottom at 6 inches, and I end up with a square. I'm going to cut this square out. Make sure that a grown-up helps you with this, just to be safe. Carefully cut my square out. If you're not exactly on the lines, that's okay. Just do the best you can. Okay, now I've got a square. I'm going to use this square to make the body of my rocket. So to make sure that my body fits around my rocket, I'm actually going to take my straw and lay it down on the paper and roll the paper around it to make sure that the body fits. So I'm going to start rolling it around the body around my straw. And I don't want to do it too tight. I want to make sure that the straw can go in and out. This is so that the rocket will actually be able to launch. Then I'm going to take some of my tape and just tape the tube closed. Okay. So then I end up with something like this. Paper tube and a straw. And it fits in nicely. Okay. Now, what else am I missing? Missing a nose. So you can design the nose however you want, your own idea. You just need to make sure that your nose is sealed so that no air can escape. So I'm going to just fold mine down. But if you want to shape yours into a triangle or into a cylinder, this is your rocket. You can do whatever you want. So I've sealed my nose down. I folded it down so now that it has a little nose. If I want to, I could make a nose out of paper, but we'll get to that later. Then I need to make some fins. So I'm going to just use the scratch paper, the scraps from before, and I'm going to cut out some fins. But here's what I'm going to do to make it a little easier. I'm going to take a piece of paper, and I'm just going to cut a little piece of the paper, and I'm going to make 3 diagonal cuts. 1, 2, 3. So now, when I fold this around my rocket, I'll have these little flaps that then I can make into fins. So I'm going to tape this piece of paper around tape it around my tube, and then I'm just going to pull up my fins. A little messy, but that's okay. You can always fix them later. You could also just cut triangles out of your paper and then tape the triangles on as well. Whatever you want to do. So I've got my fins, I've got my nose sealed, and I've got my straw. Now, we put the straw in the tube, the body of the rocket, and you blow. Let's see what happens when we test it. It's gone. Now it's time for you to test. Ready? Blast off!
What did you notice about the amount of breath that you were putting and the distance that your rocket traveled? We learned a science word last week that describes this relationship. A force. The air that you're breathing into the straw puts a force on the paper and pushes the paper off of the straw. Did you notice anything about the direction of the straw and the direction where the rocket went? What happens if you blow your straw straight up? It comes straight back down. I wonder why things that go up always go down. There is an invisible force called gravity that pulls things down to Earth. Gravity is an attraction between two objects. Bigger objects have a gravitational pull on smaller objects. The Earth is much bigger than we are, so it has a gravitational pull on us. That's why we don't go flying off into space. Now we're going to redesign our rockets to try to make them travel the farthest horizontally, so launching it this way, and track the distance of how far they travel. To make modifications, you can use any of the scrap paper that you had left over from making your original rocket. If your rocket's gotten damaged, you can also remake a new one. So when we make modifications, we're going to try to redesign parts of our rocket that we think are going to make it go the farthest. When engineers make redesigns, though, we need to be careful that we're not changing too many things at once. If we change all the things, then we can't tell what might be making our rocket go farther or not. So if we decide that we're going to change, for example, the nose cone, we can only change the nose cone and test it a few times before we try doing anything else. And then, once we do something else, you need to keep the nose cone the same. So I'm going to keep my rocket body the same, and I am only going to change my nose cone. So I've got plenty of scrap paper here. I'm going to take my scrap paper, and I'm going to make myself a little pointier nose. I think that might be successful. So I'm going to take my nose cone, and I'm going to trim it a little so it's a little smaller. And now I'm going to attach this to my rocket, and I think that might make my rocket fly a little more successfully. So right now, I'm only changing my nose cone. I'm not going to change my fins. I'm not going to change the body of my rocket. I'm not going to change the kind of straw I'm using. I'm going to keep everything the same. So I'm going to sketch this rocket on my recording sheet or on my paper. I will make a sketch, and then I'll use that same paper to track how far my rocket goes when I test it. Let's try. I used a piece of tape as a starting line to make sure that every time I was starting my rockets from the same place to make it a fair trial. Each time that my rocket fell, I marked where it fell with a piece of tape so that I could go back and measure it. If you don't have tape, you can use a toy or a book, just something to mark where it fell so that you can take your rocket back and start again. Scientists like to use at least 3 trials just to make sure that the results are pretty close to being the same so that you're not just getting a random result. I tested 3 times and I noticed that twice my rocket went 15 feet and once it went 6 feet. So I feel pretty confident in saying that my rocket went 15 feet. Now that I've tested a nose cone, if I'm happy with this result, I can keep it. If I want to try to make an even better one, I could take this cone off and then try doing something else. Remember that I'm still going to leave the body and the fins the same just to make sure I know what I'm testing.
Once I'm happy with my nose cone, then I can go to try making new fins or even maybe making modifications to my body. That's up to you. Have fun, scientists! Okay, scientists. Thanks for watching. Did you enjoy that lesson? Subscribe below to see more fun science videos. You can also become a member of PS Science on Patreon to support what we're doing. See you next time!